Hello everyone, my name is Remy. I come from the Eastaker community and I'm joined today by Ladislaus. Hello, Ladislaus, how you doing?
Hey everyone, hey Remy, thanks for having me.
Hey, so today we'll see and we will demo how to do a voluntary exit for a validator on Ethereum. So we've got this guide that we'll be following and we'll show you how to do this. But first, Ladislaus, what's your take on Ethereum? Like, what are you doing in this community? I know you've been a long-time collaborator with Eastaker. What else are you doing in here?
Oh yeah, as you mentioned, I'm happy to collaborate on some educational material with the East Staker crew. Have been a community member for or with the staking community at least for 3 years. And yeah, love what you're doing. Appreciate your efforts to promote home staking, solo staking, and continuously try to keep the validator set as decentralized as possible.
Awesome. Let's get started with the small question as to why would someone want to do a voluntary exit? What's the cycle? What's the process? How does this fit into this whole staking um, thingy that we do on Ethereum?
Yeah, so basically what we'll talk about exiting today is that the fact that we've just recently enabled withdrawals technically with the network upgrade which was called Capella. And so interestingly, stakers could exit before that technically, but it was not like there was no real incentive to do so because the initial collateral, the 32 E's, um, each validator would have had put up would not have been accessible until this recent upgrade. So with withdrawals, which we are also talking about a little bit today, and the exit process, like generating exit messages and exiting a validator with the initial collateral and the accrued rewards become accessible. And that's basically what we are taking a closer look at today.
All right, let's switch into the meat of thing and let's go into the actual demo. I'll be sharing my screen here and so we'll be able to see. All right, so we are into this guide here, which we will link into the description of this video on how to perform a voluntary exit. So there's very many different ways on how to do this, right? And so each client, each of the consensus client have their own native way of doing this, but the way we're gonna show here is more generic and it can be performed without even having access to a consensus client, right? So that's one of the benefit of this way. But like I said, there's a lot of different ways of doing this. So let's get started. The tools that we're going to be using, we'll be using three tools: IFDU, the beacon chain broadcast tool, and Tails. IFDU is a great command line tool for managing a bunch of tasks in Ethereum. It'll actually do all the crypto stuff to sign our voluntary exit. Beacon Chain is a very popular Ethereum Explorer, and it has a nice little utility page called the Broadcast Sign Message tool, which can be used to broadcast a voluntary exit. So we'll be using that because it's very easy. That's not the only way to broadcast it, and we might talk about an alternative to this. And Tail is simply a nice portable operating system that protects you against surveillance and malicious actors. So let's get started with the required details. In this demo here, we'll be doing two exit on two different validators on Girly. And so I went ahead and prepared those ahead of time. We'll be exiting validator 473895 and 473896 in two different ways, simply to demo these ways. And so we can see right now that these validators are online and performing their duties, and that they also have a withdrawal address associated with them. And so we can see the partial withdrawals right now on the Beacon Chain website. So I'm using right now the girly version of the Beacon Chain website, but the mainnet version is very similar. So these are the two validators that we will be exiting. This is the validator index, which we might need for one of the ways of performing this exit, and we also have like the public keys that I just noted here. So those are the
Okay, so
things. Go
just
ahead.
just to quickly add, yeah. I think the important part to highlight here is that you've already broadcasted a different message, the BLS to execution message, which each taker has done. Also, a video on how to generate those messages, so that validators that were initially activated or deposited with a BLS credential now change this credential to a regular Ethereum address. So
So
will
that's a good
become
point,
probably
right?
will
We're not going to show here how to add a withdrawal address to your validator. This is assuming you already have one. If you don't have one, what will happen if you don't have a withdrawal address associated with your validator and you exit from the network?
I would assume I've not tested this, but basically you can exit anyways. So it does not affect the exit message or the exit operation, which we are demoing today. But basically the final step of withdrawing the funds, or being withdrawable, let's say technically the state of being withdrawable, and then sort of basically receiving assets on a regular Ethereum address. This would not be possible if the credential has not been set in the correct way.
Yeah, so I believe that if you exit a validator that does not have a withdrawal address associated with it, it will simply sit there until someone eventually adds a withdrawal address, right? And so these validators, to be precise, were created and deposited with a withdrawal address. So I didn't have to perform this BLS to execution change. But it's very similar to if you didn't have a withdrawal address previously and you added one with this BLS change. All right, so let's go back to the guide here. So we have the details that we need, and the tool that we will be using is F2 version 1.30 here, which can be downloaded here. But I have all the instructions here, and I'm on Windows, so I'll go ahead and do the initial part, which is preparing for offline generation. And one of the reasons why you might want to do this offline is for your own security. And there's different ways of like leaking your privacy or security if you do this online. But one of the major way you could get screwed is if you leak your mnemonic, and you want to avoid that as much as possible. So maybe I could ask you this leading question here, Ladislaus. What happens if a malicious actor get access to either your mnemonic or your key store file?
Yeah, so basically, so we're talking about the mnemonic to generate key store files, correct?
Yeah.
We're not talking about, I mean, we could also talk about the private keys generated by some mnemonic protecting your withdrawals and your collateral. So this is the mnemonic, or could also be a smart contract, whatever. So controlling the regular Ethereum address, so to say. But we're talking about the first one. So basically, you want your signing key mnemonic, as I would call it. You want to protect this because basically the easiest form of attack would be if you leak. If someone gets a hand on it, they could get you slashed, because they can, with this mnemonic, they can regenerate or generate the signing key. And as we all know, if the same signing key runs on two different instances at the same time, this is a slashable, or this could lead to a slashable offense. So keep your mnemonic safe in any case.
And I believe the other reason why you might want to keep your mnemonic safe is if you don't already have a withdrawal address associated with your validator, a malicious actor could potentially add his own address and potentially steal all your validator's balance, right? So that's a good reason to safeguard your mnemonic and to perform this operation offline.
that's a little bit more of a sophisticated attack, but yes, keep your mnemonic safe.
All right, so since
And
I'm
that's why
on
we do it offline. Yeah.
yeah, since I'm on Windows, I'll be performing this step for Windows here, but there's different instructions for Mac OS or Linux. So let's get started with the step for Windows. So the first one is to start a PowerShell. So I'll just go ahead and do that. So PowerShell is just this command line tools that you can use to perform operation on the command line interface here on Windows. The next step is to download ifdo. So I'll just be using these commands here. So this one downloads the actual archive, which shouldn't be too long here. And this other one downloads the SHA-256 checksum, which is the next step here. We'll just make sure that the SHA is correct. And so the first command here that I pasted in my command line interface on PowerShell outputted the actual file hash using this SHA-256 algorithm. And the main thing here to check is to make sure that these two values, this one here and this one here, match, right? So if you see that they match and they're the same, you should be good to go. This is just a simple precaution to make sure that what you download is actually what you're expecting, that it was not changed while it was downloaded. So if you're on 1.30.0, it should be this value here. But if you download a new version, if there's a new release, it might be different. So let's go ahead and expand the archive and start the generation for the offline file, right? So this command here will simply try to connect to your local beacon node. In my case, I don't have one on this machine. So it'll simply fall back on a public endpoint and it'll prepare a file that we will need to do this voluntary exit signing offline. So let's go ahead, let's start it. It should take a few seconds or a few minutes depending on your connection speed and if FDO can find a local beacon node. In this case, you can see that it was not able to find one, so it's going to attempt to use the mainnet fallback. This is assuming you want to do all of this on mainnet, right? So I'm doing this on Girly because this is much easier for us to demo. But if you want to do this on Girly, you will need to find a beacon node which is running on Girly. Unfortunately, there's no current beacon node. There's no public beacon node for Girly, not that I'm aware of. So you might need to run your own node to prepare this file if you want to do this on Girly. Eventually, it'd be great to have a public Girly node as well. And this might be possible in the future, and if so, I'll try to update these instructions. But you can see that it was able to generate a file called offline preparation.json, which we'll need, right? So the next step is to open a Explorer window. So I'll just type start dot, and this will show me the file that I just created. I believe I missed some step here. Sorry. I need to download the Linux version of FDO because we'll be running this on Tail, which is a Linux distro. So let's just go ahead and download these files as well. I just copy and pasted the instruction again, so that's why you don't see me typing here. But now that I have the Linux version of FDO, I should be able to go back to my Explorer and see that they were downloaded here. So those are the main instructions for Windows. I'll skip the one for macOS and Linux, and I'll go back to the section called finalizing your document. The actual element that we need on a USB stick are these three files. So the Linux version of FDO, the SHA-256 checksum, and the offline preparation. So I'm just gonna copy them on a stick here that I already plugged in. I'm gonna paste it. There's already a offline preparation file that I prepared in advance. I'll just keep the one that I already have. That one is good for girly. The one I just generated was for mainnet, so let me just go ahead and skip that, and we will have all the files that we need. So I want to demo this for the two validators as I initially showed. One of them I'm going to use a key store, and the other one I'm going to use the mnemonic. In this demo, I added a mnemonic file that includes my mnemonic, but in a real life scenario, you should really avoid inputting your mnemonic on any electronic file or devices, just to make sure that you don't leave any lingering private data that could be potentially used against you, right? We already talked about this, especially for the mnemonic. It should be offline as much as possible, or safe and secure so that people cannot easily access it. So let's keep going here. So signing and generating your voluntary exit file. In this sections, you'll be asked to create a USB stick with tails on it and boot from it. I don't want to keep you waiting. I already have a machine ready for this, and it's simply a virtual machine here. So let me just go ahead and switch to that machine. And so we have it here. So when you launch Tails from your PC or your laptop, it'll look a bit like this. You'll be prompted to select your language, keyboard layout, and different format. But you can just go ahead and click Start Tail. And I might just change the resolution here, just to make sure that it's easier to see. Let me see if I can put this slightly bigger. I should try this one maybe. There you go. So it's going to be slightly bigger for you guys to see.
So maybe to add here just quickly, Remy.
Yeah.
So you're demoing this with Tails OS, which is a privacy, or particularly privacy-oriented Linux distribution. I think we've had a couple of discussions on Discord, and it's I believe consensus is it's totally fine to also to do this with a Linux with a different Linux live distribution such as Ubuntu. The key idea here is really to do this on a so-called air-gapped machine. So let's say on a different computer which is not connected to the World Wide Web or to any other device. Let's say so.
Absolutely.
That's basically the part to highlight here.
Yeah, and one of the things I liked about Tails is I believe it does not connect on your network by default, and so that's an added protection, just to make sure you don't get screwed with any malicious software that will use your files, right? And so now I will simulate connecting my USB stick here. So I'll just connect it from my host, and eventually it should show up in the file somewhere. Let me see. There you go. My stick here is just over there, and I can see all the files that I obtained and put on my USB sticks, right? So I will need to copy all of these documents into my home folder. So let me just go ahead and do that. So let me copy those into my home folder. So it's just going to be easier to access here. Now I need to start a terminal and get starting. So if you want to start a terminal, there's like different ways of doing it, but it should be somewhere in this menu. There you go. It's in utility terminal. And let me just make it this slightly bigger for you guys to see. Now I can just make sure that the signature, the checksum for fdo is fine. So I'm just going to call SHA-256 sum on the file, and I'm gonna output the content of the checksum here, and as usual you should try to compare these two values. If they're the same, you should be good to go. This is as I mentioned previously, a sample protection to make sure that the file was not tampered while you were downloaded it. So let's extract fdo, and let's get started on creating our signatures here. All right, so we have from this point we have two different ways of generating the voluntary exit. The first one is using your key store file and the associated password. All right, so in my case, I'll do this one for the key store that I have here. So this key store here. So let me try to use this template command here and just replace. Oh, that's not gonna work here. I'll have to manually type this command because I cannot copy and paste on this machine here. So let me just type it. So fdo validator exit dash validator, and from that point here equal I will have to input the key store file. So key store dash m underscore 12 381. I might just copy and paste it instead of typing it here. That's gonna be much faster for me. There you go. Next I have to use the passphrase, which is simply the password for your key store file. So if you don't know your password, you might be able to generate it again, but in my case it's just testing 1 2 3.
Oh, there's a typo in passphrase at the end. Yeah,
you're correct, thanks. And what else do I need? So I need to output the result as a JSON value, and I have to tell fdo that I want to do this offline. And now I can choose to output the result in a file that I'll be able to give the name of. Like I can choose the name for this file, and in my case this should be validator 473896. So I'll just name this 473896-exit.json. So let's try this. Let's see if it works. Just cross my finger here because I haven't tried this ahead of time. So it seems to work. Let's just see what's inside this file. So you can see the content of the file here. It's just a regular JSON file with the epoch where this voluntary exit will be valid from, the index of the validator, and the signature for the voluntary exit. So this is the content that will need to be broadcasted eventually, right? So that's one way to do it. Let's try the other way with the mnemonic.
May I add one point here, Remy? Because I remember discussions we had on Discord. So there's important to note here, Remy has all the documents in the same folder. So the program ETHDO in the same folder as the key store. As the key store. So basically, depending on if you use different USB sticks or whatever, you can change, for example, the key store location, and if it's different from where ETHDO is located. So just make sure to, in this case, to add the correct subfolder then in the -- validator parameter here.
Good point. Yeah. Let's go ahead and try this with the mnemonic, right? So now if you don't have your key store, or you just want to use your mnemonic because it's easier for you, there's a similar way to do it. All you have to do is call this command with simply different parameters. So let's go ahead and try this for the other validator I want to exit. So it's going to be -- validator, And at this point here, I have to input either the validator index or the public key of the validator I want to exit here. So I know that I want to exit this other validator here, which is 473.895. So let's just input that, 473.895. Still want to add these other flags for JSON and offline. And
Oh yeah, by the way,
go ahead.
I forgot to mention the offline preparation JSON also has to be in the same folder, right? That's what I
Absolutely,
forgot.
yeah. And that's why I simply mention in my instructions on this guide just to copy everything in the home folder. It's just an easy way to make sure that all of these files are in there. Now I have to input the mnemonics, so let me just go ahead and do that. So I'm not gonna actually input the mnemonic manually. I'm just gonna create a new tab here, and I'm just gonna expose the mnemonic. This is just the mnemonic I'm using for this demo, so it's not tied to any real value. It's just much easier for me to do it this way. And I believe that's all, right? Yeah. If I want to output this in a file, I have to use the greater than sign and then the name of the file. Just for my own sanity, I'm gonna name this one 473.895-exit.json, so I can know this is the actual voluntary exit for this validator, the 473.895. So if I did everything
And by the way,
correctly, go ahead.
oh yeah, sorry. This is the last bit Remy added is optional, right? So if you don't provide this parameter, the naming of the file, Easter will call it, I believe, just exit operation.json, and we'll store it in the same folder, which we will see in a second, right? So we expect now that we wanted to create two messages, two different JSON files, and name them differently, which we have done here by specifying this final parameter, and those files we will now see in the same folder, right?
Yeah. So if I go back to my file browser here, I can see these two files, and all I have to do now is copy them back onto my USB stick. So I'm just going to copy them back here, and now I can eject the USB stick and disconnect it from this machine. And I should have everything I need now to broadcast the exit on the network. All right, and we're back, and we found the missing stick. There was some issue with like the stick connecting. I don't know what it was, but now we have it, and we have the two files that we created, the 473.895 exit and the 473.896 exit. Now, if I want to broadcast these exit, there's like very different ways, but like one of the very easy way to do it is using the beacon chain broadcasting tool. This is the one for mainnet. I'm gonna use the one for Girly. They're very similar. They're almost the same, but this one is gonna be the one that works for my demo here. So all I have to do is drag and drop these two files. I'll start with the first one, and when you drag it, it'll simply show its content, and then you have to go down a little and click on this submitted broadcast, and you will see this next screen here, which will show like a request job with whatever you were doing. And in this case, this is a voluntary exit, and it'll show what are the affected validator. So there's like different steps and delays from there, but if I click on this now, it should show up eventually as exited or as like pending an exit. When you go on beacon chain, there's some delays, and like it's not always showing up right away, but eventually it will start its exit process. And that's pretty much it.
And I mean, the cool part here really is that the Beacon Chain Explorer provides users, stakers, um, or heirs of stakers, for example, with a web interface. Because basically what we've done till now is uh, preparing the message, that the voluntary exit message, and now we've also submitted it via a very easy, accessible drag and drop and submit button click web interface. But for example, what stakers could also think about is just preparing the message and then storing them somewhere safely, just in case something happens to you as a node operator, and you want your heirs to, as easy as possible, access the exit message and sort of drag and drop it into the window as we've shown, and then exit for you in case you're not able to do so anymore for whatever reason. But I think it's better practice to prepare that message and not necessarily immediately exit, but that's what we are doing today.
Yeah. That could be an alternative to providing the actual mnemonic, right? So if you already have like a withdrawal address, you could provide your heirs with the voluntary exit message, and they could perform it themselves if they wanted to.
Yeah, and no need for command line here, right? Just
Yeah.
a USB stick with the JSON file in it, and maybe a quick text file, and then okay, here's beaconchain.com and the or beacon chain, sorry, and then just drag and drop and submit.
There you go. Let me just refresh this page here to see if the exit was picked up by Beacon Chain. It doesn't seem so, but let me just go ahead and broadcast the second one here. So if you want to go back to the broadcast tool, you just click broadcast signed message here, and I will broadcast the exit for the second validator, right? Nothing special. I'm just doing the same process, dragging and dropping the file and clicking on submit message here, and it'll show something very similar with your voluntary exit and the affected validator. If I click on this link here, it doesn't see that it was exited yet, and I'm not sure if there's a queue right now, which is going to lead to the next discussions about these various delays that can happen when you're trying to exit a validator. But let me go back on the Beacon Chain homepage here. You can see here there's only 2 validators that are waiting to exit the network. And I'm guessing those are the 2 that I just exited. But Ladislaus has created a nice post that explains a lot of these details here, which I will link to also in the description of this video. But one of the most interesting part that I really like, it's his diagram here on this whole process of exiting and withdrawing. And I don't know if you can just quickly go over this. I believe we've already talked about this previously in another video, but like this is very valuable to anyone who's willing to do a voluntary exit.
Yeah, absolutely. So basically what Remy has done up until this point is or starts in the upper left corner, right? So we've just broadcasted the voluntary exit message to the network. But explicitly, the Beacon Chain nodes have sort of, once we have clicked submit, have submitted this message. And basically this diagram just shows what happens from here on, from in terms of stages, what the validator then the stages they will the validator will go through. So just briefly, to highlight here, we have initiated the exit. We're waiting for it to be queued. Then we will see at some point it being exited, withdrawable, and withdrawn. And yeah, basically right now I believe it's still in the message is still being processed, so to say, until it's picked up and included in a block. Then it's reached the, as it stated, the queued phase. And usually, or right now we've seen the execute is, at least the mainnet, it's empty. So what then starts, it's about a minimum of a 4 epoch delay, so half an hour we wait for the validator to go through the queue. And particularly important here is your validator still needs to show up for consensus due dates. So keep on running your node, and yeah, do not turn it off prematurely. And then you can check on an explorer or on your local node, for example, when you screen the logs, has it reached the its exit epoch, which we also see on Beacon Chain, for example. And once it has reached the exit epoch, it is officially exempted from consensus duties and officially exited. So if the queue is empty, this might take just half an hour. If the queue is rather crowded, it could take days, potentially weeks. But once it's exited, there comes another delay phase, which is like a fixed for security purposes, fixed phase called withdrawal delay. Takes about 27 hours. And then finally, when, as we mentioned earlier, when you've set your withdrawal credentials to a 0x01, so regular Ethereum address, which is a little bit out of scope of this video, but we've talked about in other videos, this famous round robin cycle withdrawal processing, which is an automatic process, happens. And once sort of the beacon chain has reached your exited validators index, all of the collateral, like the 32 ETH, and the accrued rewards will be magically swept to your withdrawal address, which is your regular Ethereum address once again. And there you are. Or the validator has finished its journey.
And this is all conditional on you having a withdrawal address, right? So if you don't have a withdrawal address associated with your validator, and you exit, the withdrawal phase and withdrawal processing will not work. It'll just be idle until someone or you add a withdrawal address eventually.
Yeah, the funds are just are not gone, right? They're still stuck on the beacon chain, so to say.
They're simply on the validator's balance, right? So I believe that's all that we had here. So I believe we managed to exit our validator, and we're simply waiting for the exit message to be picked up by Beacon Chain. Let me just double check if it was seen. So you can see this one here, the 473895. Now has changed to this exiting status. I'm not sure what that exactly corresponds to in your diagram here. Maybe this is just the initial exit message processing.
It's been picked up in a block.
Oh, there you go.
As far as I understand, it's been picked up in a block, and once the button is sort of green, it's exited. So that's basically after 4 epochs, or minimum of 4 epochs, and the queue, it's exited.
Awesome.
So right now don't shut down your node right now, because you still have to show up for duties.
Absolutely. That's a good point. Is there anything I'm missing here, or is that it?
I believe we should, or I'm not sure whether we highlighted that you can broadcast your message, not necessarily with a drag and drop beacon chain interface, but also with different methods.
That's a good point, right? So in my guide, I also have this alternative to using the Beacon Chain website. Beacon Chain is very easy to use. Even my grandma would be able to use it, probably. But there's different ways that could be used. Like think, for instance, if Beacon Chain was down, or if there was an issue somewhere with internet or anything, you could use your own beacon node to do this broadcast step here. This might be harder if you don't have access to a beacon node, but it's still possible. So on Linux, you could simply post to this API on the beacon node public endpoint, and you could simply broadcast the exit file, and it would be very similar to what we just did, right? So your validator would enter these exit phases, and eventually, if you have a withdrawal address, you would be able to obtain all the validators balance.
And then there's, maybe to add to that, there's also like your consensus client of choice, which can also pick up the message and broadcast it. So if you follow your official client's documentations, there's a way to or there are ways to exit validators, as
Yeah, and
Remy
I have the
mentioned
link
in the beginning.
to
Yeah.
all of these docs here. So if you're using one of these, Prism, Nimbus, Lodestar, TechU, Lighthouse, simply click on these link here, and it'll take you to the part where it says how you can do this whole process with your client, for instance.
And ETH2 itself also has the functionality, or includes the functionality to broadcast the message. And that's maybe one thing we didn't highlight. Why do we use ETH2 anyways? Because it's an incredibly powerful tool for peak chain operations, as we've seen. And then also, maybe if you're wondering, like, why aren't they using like the Ethereum Foundation's deposit CLI, right? Which is likely the tool you used to create or generate your validator keys earlier. And this is simply because the functionality for generating the voluntary exit messages are not yet supported. At least the last time I checked it. So that's why we're not using, as of now, the official deposit CLI from the EF, but rely on ETH2 by a highly renowned community members, Attestant. So I think it has already been audited, the last versions of it. So it's a super powerful and reliable tool.
And eventually you might have this feature in the staking deposit CLI tool as well. I'm working with someone else to get it there, but we'll see how it progresses, right? So that's pretty much it. If you need support, if you have any issues with all of this, you can always come to the ETH Staker community, and we'll try to guide you or help you with any of the issues that you might be seeing while trying to do these. So that's pretty much it. Thanks for joining, Ladislaus. It was a pleasure to have you again. We should do more of these videos with you. You're a very good reference, and it's always a great time.
Thanks, Remy. It's been fun.
All right, thanks everyone. We'll see you in the next one.